胸の中にあなたのことだけ思うのやめるべき心からさよなら
Hello, my name is Andrew Jovanis Regar, and I am with Jason, Carmen, Vanessa, and Groba Sintoti. And we are the Standard Deviation 101. And today, for this math project, we are going to teach you Standard Deviation.
Hah? Kerobosin Tuti?
Me and my girlies, we gon' party till it's early. We're feeling all the worry tonight. Caught in some traffic, but the radio is blasting triple red light, and we're saying goodbye.
One, what's standard deviation?
So standard deviation helps us understand whether a certain data set is going to be different or more spread out from the mean. So a higher standard deviation means that a data set is going to be further away from the mean and it's more varied, whereas a lower standard deviation is going to show that it's closer and less spread out from the mean.
Hey, I know it's been a while. I saw a pic of you the other night. I won't lie, you still look fine. Can we make it up just one more round?
Andrew, have you measured this tree?
So guys, basically what we've done is we're measuring the heights of the individual trees and we're just finding the standard deviation of those trees. What is standard deviation?
Huh?
What is standard deviation?
Is it DV? Yeah, it's something. We use formula for that. I don't know.
Global asymptotic.
So here is the equation on how you can find the standard deviation from your data values. And the x here represents your data value, whereas the n here represents how many data there are in the population that you are using.
And the x with the line on top, that means it's just mean. And without the square root, that means it's just variance.
So therefore, to find the standard deviation, you'll have to take each of the data value and find its square and find the total of them divided by the number of data that there are in the population, and afterwards you subtract the mean squared from all of them, and when you find the square root of it, you'll get the standard deviation, and this will tell you the variance of the data, how far they are spread out from the mean.
But wait, that's for a group data. To find the standard deviation of group data, we just have to find the sum of the frequency multiplied by the squares of the mid-value of each of these classes and then dividing it by the total number of trees in our sample. Then we subtract the mean square from it, giving us the variance. And to find standard deviation, what we need to do is square root that variance. And well, the reason we're using this formula is because the data that we are gathering is the height of trees. Heights can vary from length to length and is a continuous variable. Therefore, to ensure that we have better clarity for comparison between the trees, we will group their heights to their ones place, with the 8 to 9 meters class consisting of the tallest trees and the 4 to 5 meters consisting of the shortest trees. This method of grouping data in classes also allows us to ensure a more accurate estimation for the entire population using our limited sample. So guys, I'm officially hijacking this video. Welcome to Jason's vlog.
Ready?
So we're going into the room. What's good, gang? Huh? Welcome to our cabin.
Nice jacket and
Thank you. This is our cabin. Okay, bye bye. So, guys, we just checked in and we're filming stuff. Standard deviation.
Come on, Dana.
Yeah, it's okay.
Okay, who?
Hey, what's poppin'? It's your boy Iron to Dynamic. We out here, we Madu FE, we kabun Madu FE.
Pasok to me.
Thank you, man. Thank you, man.
Ofo.
I don't have any. Good line. Hey, good in your hand, man. Good, lor. Hey, of course,
So guys, I've deviated from the group. I'm hiding. So firstly, to find standard deviation, we'll have to find the values in the formula. So to find the mean, which is x bar, we'll have to find sigma xf and sigma f. To do that, we'll have to find the total values of xf and the total values of f added together, and then you'll get sigma xf, which is 63.0, and sigma f, which is 10. Divide that 63.0 by 10 and you'll get 6.3, which is our mean of the height. And to find the standard deviation, you'll have to find sigma x square f as well. So what you'll have to do is add the total of all of the x squared times f values, which is 416.50, and put that into the equation. So we'll have the square root of 416.50 divided by 10 minus 6.3 squared. That gives us 1.4 meters. Now that is the standard deviation of the height of the trees. The high value tells that the human controlled environment conditions have a considerable impact in resulting in taller trees.
So using the information we have gathered, we can actually make use of it in order to predict probabilities. So let's say that our sample is just an estimation of what is likely to happen towards the entire population. And let's consider Madu FE to contain 100 triangular trees in total. So if we assume that being tall means that the tree is between 7 to 9 meters, then using our sample as an estimation, because we have 3 trees that is within that class range compared to the 10 trees that we have in our sample, we can assume that the probability for a tree to be tall is 0.3. However, this gives us the binomial distribution that within the population of 100 trees, 0.3 is the probability for it to be tall. And because we want to basically assume it using normal distribution to be able to gauge a better probability for that in any type of circumstance. So for example, if we want to know what is the probability for X number of trees to be tall or less than X number of trees to be tall, we have to use normal distribution. And in order to convert our binomial distribution to normal distribution, we have to do a series of methods that involve approximation as well as continuity correction. So if we want to know whether it's viable for approximation or not, we have to check whether NP and NQ is greater than 5, in which N is the 100 total trees in the population, P is the probability for a tree to be tall, and Q is the probability that the tree is not tall, which is 0.7 from 1 minus 0.3. And after checking, both of them are viable for normal distribution. So the first thing that we have to do is doing approximation. So for us to have a normal distribution, the first part will have to be the mean, followed by the standard deviation squared. So the mean is actually approximated to be NP, and the standard deviation squared to be NPQ.
Now that we have this information, we can write the normal distribution as open parenthesis 30, 21 close parenthesis. With this, we can find the probability that there is more than 27 tall trees in Madu Fe. In order to do that, we'll have to find the probability that there is less than 27 tall trees in Madu Fe by using a suitable approximation, and we'll subtract that from 1. So, to do that, we'll first find the probability that there is less than 27 tall trees in Madu Fe. We'll write it out as P, open parenthesis, Z is smaller than 27 minus 30 over root 21. Now, we'll find that probability using the graph or the chart, and we'll get 0.7438. So once we have that value, we'll subtract that probability from 1, which will give us 0.2532. Hence, we can say that the probability that there is more than 27 tall trees in Madu Fe is 0.2532.
By constructing the 7-leaf diagram and calculating the values for the interquartile data as well as the median, we can basically plot a box and whisker diagram that shows us that the trees that are found in the human-controlled environment are generally taller but more widespread compared to the trees in the wild.
들리진 않지만 보여, 느껴져. 넌 음악할 때 제일 빛나, 가장 멋져. 그러니까 나 신경 쓰지 말고 프론트맨답게 작업 열심히 해. 나 안 심심해, 소외감도 안 느껴. 눈도 있고, 심장도 있고, 할 일도 있어.
Your boyfriend steal my Duolingo.
Dedication.
You swear already?
Yes. What?
Please don't have somebody.
Good aligning. Hey, good in your hand, man. Good, no?